Then next we need to look at operating leverage. And operating leverage indicates the degree to which the company's costs are fixed. And a company with high fixed costs will have a high operating leverage. So how do we calculate the degree of operating leverage? You take contribution and you divide by operating profit. So please study that formula. Now I want you to assume that you've performed this calculation and the degree of operating leverage is 5. If you have an answer of 5, that means for every R1 change in sales, profits will change by R5. So if sales increase by R1, profits will increase by R5. However, if sales drop by R1, profits will drop by R5. Now I want to go to the lecture example to explain the rest of the logic on this page. And after we're done with the lecture example, you guys can come back and everything over here will make a lot more sense. So let's jump to that lecture example. Freeman Limited needs to choose between 2 different production processes. So just below, you've been provided with information relating to an automated production process and also information relating to a manual production process. Now you can see the manual process has a higher variable cost per unit, and that's because the manual process won't really include a lot of machinery, but instead the work will be done by laborers. So the manual process will have a higher direct labor cost. On the other hand, the automated production process will involve the use of machinery. So you can see the automated process has higher fixed costs per annum. The selling price per unit is R50 and sales are expected to be 30,000 units per annum. In the first part of the required, you need to calculate the break-even point, margin of safety, and contribution margin for each production process. Now guys, these are very straightforward calculations, so please, I want you to make sure that you are happy with the calculations. In this recording, I am going to focus on the discussion around those calculations. Let's first look at the break-even point. You can see that the automated production process has a higher break-even point. So if the automated production process is used, the company will need to sell more units in order to break even. And the reason for that is because the automated process has higher fixed costs per annum. So you can see that discussion just below. The automated production process has higher fixed costs. This results in a higher break-even point as more units need to be sold to cover the fixed costs. So from this calculation, we can conclude that the automated production process is more risky and the manual production process is less risky. Then remember, the margin of safety tells us the maximum that sales can decrease by until the break-even point is reached. Or in other words, the maximum that sales can decrease without incurring a loss. So if the automated production process is used, sales can decrease by 58.33% before a loss is incurred. On the other hand, if the manual production process is used, sales can decrease by 66.67% before a loss is incurred. So the manual production process is less risky because sales can decrease by a larger percentage before a loss is incurred. And obviously then the automated production process is more risky. So I want you to assume that sales drop by 60%. If sales drop by 60% and the automated production process is used, Freeman will suffer a loss. On the other hand, if sales drop by 60% and the manual production process is used, Freeman will still report a profit. So the automated production process has a lower margin of safety. And the reason why it has a lower margin of safety is because of the higher break-even point. You can see that's the only difference in the calculation above. Everything else is exactly the same. So because the automated production process has a lower margin of safety, that means a smaller decrease in sales will result in losses. So we can conclude by saying that the automated production process is more risky than the manual production process. Then if we look at the contribution margin, the automated production process has a contribution margin of 80%. So that means if sales increase by R1, contribution will increase by 80 cents. On the other hand, the manual production process has a contribution margin of 60%. So that means if sales increase by R1, contribution will only increase by 60 cents. So if sales are increasing, the automated production process will outperform the manual process. However, if sales decrease by R1 and the automated production process is used, then contribution will decrease by 80 cents. On the other hand, if the manual production process is used and sales decrease by R1, then contribution will only decrease by 60 cents. So again, this is telling me that the manual process is less risky and the automated production process is more risky. Now I want you to remember the relationship between risk and return. The automated production process is more risky because when sales drop by R1, contribution will drop by 80 cents. On the other hand, if the manual production process is used, contribution will only drop by 60 cents. So if the automated production process is used and sales are decreasing, contribution will decrease by a greater extent. But remember the relationship between risk and return. The only reason why Freeman would consider taking on this risk is because there is a potential for a higher return. In good times when sales are increasing, the automated production process will outperform the manual production process. And that's because as sales increase, contribution will increase by a greater extent. All right, so please read through everything just below. I have discussed all of that with you. Then in part 2 of the required, you need to calculate the degree of operating leverage for each production process. So once again, please make sure that you are happy with the calculation. You can then see that the automated production process has a higher degree of operating leverage and the manual production process has a lower degree of operating leverage. And the reason for that is because the automated production process has higher fixed costs. And the higher fixed costs result in a higher operating leverage. Go back to your lecture notes. You'll remember I said to you, the operating leverage indicates the degree to which the company's costs are fixed. A company with high fixed costs will have a high operating leverage. So because the automated production process has higher fixed costs, the automated production process has a higher operating leverage. Now, whilst we are here, we can also discuss this in more detail. A high operating leverage will result in a higher break-even point as more sales are needed to cover the fixed costs. So we can confirm that we did calculate the break-even point for both production processes, and we saw that the automated production process had a higher break-even point. In addition to that, a high operating leverage results in a lower margin of safety. So in other words, a smaller decrease in sales will result in losses, and that is due to the higher break-even point. So once again, if you go and refer to the margin of safety calculation that we performed, you'll see that the automated production process did have a lower margin of safety. Then finally, what we need to discuss in more detail is a high operating leverage also results in greater volatility of profits. So let's discuss that in a bit more detail. if the automated production process is used and sales increase by R1, then operating profit will increase by R1.71. On the other hand, if the manual production process is used and sales increase by R1, operating profits will only increase by R1.50. So when sales are increasing, the automated production process will outperform the manual process. On the other hand, if sales decrease by R1 and the automated production process is used, operating profits will decrease by R1.71. If the manual production process is used and sales decrease by R1, operating profits will decrease by R1.50. So you can see that the automated production process has greater volatility of profits. Profits change by a greater extent when there's a movement in revenue. And that makes the automated production process more risky and the manual production process less risky. Once again, the discussion here is very similar to the discussion that we had with the contribution margin. The automated production process is more risky because when sales are decreasing, operating profit will decrease by a greater extent. On the other hand, remember the relationship between risk and return. The only reason why Freeman would consider taking this risk is because in good times, when sales are increasing, the automated production process will outperform the manual process because operating profit will increase by a greater extent. So a high degree of operating leverage also results in greater volatility of profits. So because of the higher break-even point, the lower margin of safety, and the greater volatility of profits, a higher operating leverage leads to higher risk. And this is confirmed with all of the calculations that we performed. We concluded with each calculation that the automated production process with the higher operating leverage was more risky than the manual production process. However, it's important to note that even though the automated production process is more risky, this risk provides the potential for higher profits. All right, so we've covered all of that discussion. You can move on to the next page. In part 3 of the required, you need to calculate the sales volume where the two production processes are equally profitable. So in other words, you need to calculate the changeover point. So once again, I want you to go back to your lecture notes. This is the formula for the changeover point, so please make sure that you study the formula. Now guys, the changeover point is useful if you are required to compare different cost structures, either within the same company or different cost structures of different companies. And the changeover point is the output level where the profits of both alternatives will be equal. So in other words, it is the point of indifference. So in our lecture example, I want you to calculate the changeover point. And the changeover point will tell you the sales volume where both production processes are equally profitable. So it's the point of indifference. It doesn't matter if the company uses the automated production process or the manual production process. At this output level, profits will be equal. So you'll see it's a very simple calculation. Please make sure that you are happy with the calculation. We get a changeover point of 20,000 units. So that means if Freeman Limited produces 20,000 units, it doesn't matter if they use the manual production process or the automated production process, because at this output level, profits will be equal. And you can see I've also included a proof for you over here. I've calculated what the profit will be if the automated production process is used and what the profit will be if the manual production process is used. And you can see at an output level of 20,000 units, the profits are equal. So the changeover point is important because at this output level, it doesn't matter whether the company uses the automated production process or the manual production process because the profits will be equal. Then in part 4 of the required, you need to identify the range of sales for which the manual process is more profitable than the automated process. And, so be careful, there's 2 parts to the required over here. You also need to indicate which process is more profitable if 30,000 units are sold per annum. Now guys, if you go back to the lecture notes, you'll see I have included the decision criteria for you over there, but let's apply the decision criteria to this example. So here's the decision criteria again. So we know if they manufacture and sell 20,000 units, that is the changeover point. At that point, both processes are equally profitable. However, if the sales volume is below the changeover point, so in other words, if the sales volume is less than 20,000 units, then the alternative with the lower fixed costs will be more profitable. So the manual production process has lower fixed costs. So if the company sells less than 20,000 units, so in other words, if they sell 19,999 units, then the manual production process will be more profitable. Now you just need to be careful. Obviously the break-even point is going to affect this because you need to identify the range of sales for which the manual process is more profitable than the automated process. And obviously, if the company sells less units than the break-even point, then this process will not be profitable. So you need to go back to your break-even point calculation. We calculated the break-even point for the manual process to be 10,000 units. So if the manual production process is used and 10,000 units are sold, Freeman will break even. They won't make a profit or a loss. So again, go back to the required. Identify the range of sales for which the manual process is more profitable than the automated process. So obviously, if the manual production process is used, the process will only be profitable if Freeman sells more than the break-even point. So the range of sales where the manual process is more profitable will be between 10,001 and 19,999 units. All right, so please don't get confused over here, guys. The reason why the manual production process is more profitable is because the sales volume is below the changeover point. So if the sales volume is less than the changeover point of 20,000 units, then the alternative with the lower fixed costs will be more profitable. So the manual production process has lower fixed costs, and the manual production process is therefore more profitable if the company sells less than 20,000 units. But you do just need to take the break-even point into account in this discussion, because obviously if the company sells less units than the break-even point, then they won't be profitable. Also, if they sell 10,000 units, they're not profitable either, because that's the point where they don't make a profit or a loss. So they will only start making profits when they start selling units above the break-even point. Then again, go back to the decision criteria. If the sales volume is above the changeover point, so if the sales volume is above 20,000 units, then the alternative with the higher fixed costs will be more profitable. So the automated production process is the alternative with the higher fixed costs. So if Freeman sells more than 20,000 units, the automated production process will be more profitable. So if the sales volume is 20,001 units or anything above that, then the automated production process will be more profitable. And guys, you can just quickly perform profit calculations and you can prove that. Calculate the profits at various different output levels and you'll see which process is more profitable. Then be careful, there was also a second part to the required over here. Indicate which process is more profitable if 30,000 units are sold per annum. So guys, 30,000 units is obviously above the changeover point of 20,000 units. So the alternative with the higher fixed costs, or in other words, the automated production process, will therefore be more profitable. So if 30,000 units are sold per annum, the automated production process will be more profitable than the manual production process. Now, once again, guys, you can prove this. Calculate the profit. Remember, we calculate profit by taking sales minus variable costs minus fixed costs. Calculate the profit for both the manual and the automated production process at an output level of 30,000 units. And you'll see the automated production process is more profitable. All right, that then brings us to the end of this lecture. Thank you.